Good morning Year 5, here is your answer video for Wednesday's work. So hopefully you've had a good go at these questions and that you found the fraction video about equivalent fractions helpful that you watched earlier on. So these were the questions for today and let's see how you got on. So the first addition question, this week we've been practicing adding more than sort of 2 or 3 numbers together. It's really important to have strategies available to you when you're starting to add more numbers together. You need to be able to work flexibly, so not just setting that when you add numbers together it's always 2 numbers you're adding together. You need to be ready to add more numbers together and have a strategy that works for you. So I've set this up as a column addition. And when we're looking at it, we can see that it's been quite complicated to set up because there's lots of variety with the numbers. When I say variety, there's lots of differences. So you've got a number here that has got 1 decimal place. You've got a whole number here with no decimals. A number here that's gone to 3 decimal places, has gone into the thousandths. And then a number here that's quite a small number, but it has 2 decimal places. So my first thing I'm going to do, and as you can see, I've done it in order, started from the biggest to the smallest. The first thing I'm going to do is to make sure my numbers match the question, because there's no point me working really hard and doing all of this addition and getting it wrong because my numbers don't match. So I've had a really careful check and yeah, everything matches. Now before I'm going to start calculating, what I'm going to do is to make sure that every number for me has a decimal point. That's the first job, okay? And I'm going to make all of the numbers have the same decimal places, so the same amount of numbers after the decimal point. And that is just really clear for me so that I'm making sure I'm adding the numbers in the right columns, because sometimes, particularly if you don't use your squares in your book properly, and you should be making sure that you've got one number in each square, but if we don't do that then we can sometimes think that this number is in that column. So now I'm going to put my decimal point in. Okay, and like I did on Monday, I'm going to start to look for pairs of numbers that add together really easily. So this one is easy because there's only 5, the rest are zeros. 8 and 8, so double 8 is 16. Okay, I'm going to try and do that neatly. Okay, I'm going to carry over the 1 here, and I've got 9 and 1, that makes 10, and then add 3 is 13. When you're adding more than 2 numbers together, it is important just to scan down the column and look at all of the numbers first of all, because you could have done 9 add 3. It wouldn't have taken you too long, but actually 9 and 1 takes you to 10, which is really easy to add 3 to. Okay, I'm 6, 8, 4 and 1. So I'm going to do 6 add 4 is 10, 10 add 8 is 18, add the 1 is 19. You see, I'm not actually having to do any counting. I'm just adding numbers that I can add together really easily. 5, 10, 15, 16, 17. Okay, and then I've got 4 and 1 is 5, add the 1 is 6. So your answer is 679.365. You can put a 0 there, okay, if you want to. It's the same as putting it here, but I didn't feel like I needed that, but you can do if you wanted to. Okay, hopefully you found that easier than the one that we did on Monday. Right, second one. These are some interesting subtractions now. Lots of you would have presumed will have gone straight to doing column subtraction, and it wouldn't actually have taken you very long. However, when you look at the first number, so this number here, okay, if you're really good at partitioning the number, so you're understanding what each digit is worth, you can see we're taking away 400,000. And in the 100,000 columns, you've got 400,000. So you're actually just going to take away that 4, and there's going to be nothing left in that column. Okay, so if you take out that 4 and replace it with a 0, you have taken away 400,000. So your answer is 1,096,456. So you should have, even if you did column subtraction, have got that answer. So 1,096,456. But hopefully you can see that you didn't actually need to do a sum there at all. If you looked at the number just very quickly, you will have noticed that there was 400,000 in the 100,000 column. So you could have just got rid of that and replaced it with a 0. Okay, same if it was this number. Okay, so before I did anything to it, this number, take away 50. Okay, if you look at the tens column, there's 50 there, and you could have replaced that there. So with the questions that follow on from today, just have a look and see if you can use your place value understanding rather than complete a sum. Okay, so we're carrying on with long multiplication this week. It's really good to keep practicing this. So I've set it up, okay, and I'm imagining that I've got one digit in each square, okay, and then I'm going to make sure as I keep working that my numbers stay lined up. So then when I'm adding them together, I'm not going to get confused. I'm crossing out any that I've carried over, so that I'm really clear about the fact of the numbers that I'm adding together. So this line here is going to be really simple. It's going to be 5 times 708. And then this is where we need to remind ourselves about what we need to do, because we're timesing by the tens column. So 5 times 8 is 40. Okay, I'm purposely this week using, still using numbers that, times tables that most of you know. When we come back to school in the next few weeks, I will be using sort of other times tables, because you need to practice working with times tables that you're not overly familiar with, particularly those people who don't know many times tables. We've got to use that strategy that we practiced last week if we're trying to work out a times table using those facts that we know. So instead of doing the 8 times table, I've used the 5 times table. 5 times 0 is 0. Add the 4. Okay, I've crossed that 4 out to make sure I don't add it up at the end. 5 multiplied by 7 is 35. Okay, I'm keeping everything lined up. So the 700 is in line with the 500. I'm not going to add these numbers up at the end, but it's helpful to keep it in the same column. Right, now what I'm going to do is remind myself that we're multiplying by the tens column. So I could show you, well, I will show you again. If you've forgotten that we need to put a 0 in, I'm going to show you why it's important. 2 multiplied by 8 is 16. These are our 2 times table. 2 multiplied by 0 is 0. Add the 1. Okay, 2 multiplied by 7 is 14. Okay, we finished that calculation, so we don't have to carry over. So like I showed you, that is the answer to 2 times 408. Okay, double 708, double 708. I'm actually trying to do 20 times it, so it's going to be 10 times bigger. So I need to move everything up, okay, and then I need to put a 0 to hold that place value there. Okay, you can see I've moved that by accident as well. So what we don't want to be doing, and I can't move it back, so I'm going to have to leave that line there. What we don't want to be doing is rubbing our number out and then adding the 0 in afterwards. That's why we show that we know the answer is going to move up one column and we're going to be left with a gap. So we automatically put that 0 in. Okay, now all we need to do is to add the numbers together. So 0 add 0 is 0. 4 and 6 is 10. 5, 6, 7. 3 and 4 is 7, because 3 and 3 is 6, it's one more. Okay, so your answer is 17,700. Hopefully this is becoming more familiar with you or to you, so you should now be remembering when we get to multiplying by the tens column, we're automatically going to put that 0 in. Okay, so this was the equivalent fractions that we've been looking at, and in the video I spoke this morning about the fact that you can complete equivalent fractions with any fraction. It doesn't just need to be ones that you know really carefully, like 1/3, 1/2, 1/4. We could have 75 over a million, and so long as we do the same to the top number, the numerator, as we do to the bottom number, the denominator. Okay, so if we're going to multiply 1 by 5, we need to multiply the other one by 5. We'll ensure that we have an equivalent fraction. So we're looking now at what is the relationship between 2 and 4. You make it twice as big, you're doubling it, you're timesing it by 2. So I must do the same with 3. So that becomes 6. So 2/3 and 4/6, or 4 over 6, or 2 over 3, they are equivalent fractions for each other. If somebody said to you, you can eat 2/3 of I don't know, a bag of grapes, or you can eat 4/6 of a bag of grapes, they're saying exactly the same thing to you. So now I'm trying to find the numerator. That's where my gap is. So I'm going to come straight back to this one, and I'm going to go to the new denominator. So it's gone from 3 to 30, which is multiplying by 10. Okay, so I need to do the same to the top number, the numerator. So it's 20 over 30. So 20 over 30 is an equivalent fraction for 2/3. Okay, now we're finding the denominator. So I'm going to look to see what happens to my numerator. It goes from 2 to 22. That makes it multiplied by 11, or 11 times bigger. So I need to do the same to the denominator. So it becomes 22 over 33. Okay, hopefully again this is becoming a bit more familiar to you, and all the time you're just looking at the information that you've been given, so the information here in green, and finding the connection. Okay, so if you've got the numerator, look at the original, the first numerator, what's happened to it. If you're trying to find the denominator, look at the original denominator, what has happened to it. Okay, so we're over to the other side of the board now. We've got three numbers we're adding together. We make sure that the numbers match, they're lined up. You're using squares in your books. Okay, so 2 add 8 add 9. Well, 8 and 2 is a number bond to 10, add 9 is 19. Okay, so I'm going to put my 9 in. Hopefully you can see this with the yellow. All right, I've got 8, 5, 6 and 1. So I'm going to do 5 add 1 is 6. 6 add 6 is 12. Okay, I'm doubling 6 is 12. 12 add 8 is 20, because in 12 you've got a 10, okay, and you've got a 2. 2 and 8 give you 10, and there's another 10 there, so it's 20. Okay, carry over the 2. 7 add 4 add 3. Okay, 4 and 3 is 7. 7 add 7 is 14. And that's 16. Now you don't have to do it the same way as I'm doing it, but I am looking for pairs of numbers that add together really easily. You could have done 7 and 3. Okay, add 10, add 4 is 14, and the 2 is 16. So there's different ones you could do there. And actually, when you look at it, sometimes some number pairs jump out to some people when other number pairs jump out to other people. So just work in a way that is efficient for you. So it's the fastest way where you're not going to make mistakes. So the answer is 2,609. Okay, so with our subtraction today, we have got fractions, and this arrow was linking to a message to you saying draw something if you're not quite sure. So when you look at this looks quite tricky, and those of you who have been completing the fraction questions should be much more familiar with this, and maybe you didn't need to draw anything or write anything down. But for those people who are thinking, oh my goodness, this PA is too hard, okay, I have got 3 wholes, okay, 3 whole fractions. They're divided into quarters because that denominator shows me that. So I've got 3 wholes. Each of them have got 4 quarters coloured in, and then I've got 1 quarter. So I have represented that in a diagram. Now I need to subtract, okay, 3 of those quarters, so 3 of those equal parts. So I'm going to get rid of that one. 1, 2, 3. If you want to cross them, that's fine. Okay. Then my answer is, what do I have left? So I still have that complete. I still have that complete. So I've got 2 wholes, okay, and then I've got 2 quarters. Now, you could also have said you've got 2 and a half. Okay, that is an okay answer. Either of those answers would be completely fine, because when you look at it, you've got 2 wholes, and then you've got half of the shape left. Okay, so 2 quarters is an equivalent fraction for a half. If we half both numbers, we get a half. If you decided actually I was going to do a what we would call an improper fraction, where we're just going to count up how many equal parts we've got. So we've got 4 there, 8, 9, 10. Okay, so 10 over 4. All of these are equivalent to each other. They all mean the same amount, but they're expressed in different ways. These two are mixed numbers, okay? That is correct, that is correct, and that would be correct. Okay, so any of those answers you would get the answer correct. Okay, again we're looking at some harder, okay, not too hard, but some harder multiplication, but we're always going back to what we know. So we're dividing this number by 100 and this number by 10 to give us 4 multiplied by 5. So 4 times 5 is 20. So we're now going to times by 40 instead of 4. Our 5 stays the same, so our answer is going to be 10 times bigger, because the 4 is 10 times bigger. It's now 40. I'm going to make that 10 times bigger again, so our answer will be 2,000. Each time so far the 5 has stayed the same. We're only changing one thing at a time, and the more you do this, the more you will be able to say, actually I had to divide that by 100 and that by 10. Together I had to divide by 1,000, so I need to multiply my answer by 1,000. But for most people, I want to just do it step by step. So my 400 stays the same, but my 5 is 10 times bigger. Okay, so that is a terrible 0. Excuse me. Okay, so your final answer is 20,000, and hopefully your handwriting is much better than me on a computer. But as you can see, I'm going step by step. this is a really good example of if you can be bothered to take the time to do it properly, you're going to get the right answer. If you try and skip some steps because you can't really be bothered, or you just want to get it over and done with quicker, you're probably going to make some mistakes. So what I'm saying to you is do it properly until you feel really confident, and then you can find some faster ways. But you've got to use your understanding of 4 multiplied by 5 and then change one thing at a time. Okay, so this was our word problem for today. So a person faces north, okay, doesn't matter whether it's a person, a dog, doesn't matter, and does a complete turn. Okay, so they go in a whole circle, so they are back facing north again. How many degrees have they turned? So if I'm looking here, we have two lines, two straight lines that cross, okay? And in the coming weeks, I'll talk to you about what that's actually called. But hopefully you know at the top is north. What is opposite north? Okay, south, and then east. And you've probably been told about never eat shredded wheat and things like that. So opposite of north is south, opposite of east is west. Now the code for today to get your 10 dojo points is, what is this? What is the name of this? If you can message that to me, you will get 10 dojo points. But it has got north, south, east and west. Okay, so the person starts here, okay, and they do a complete, I'm going to use a different colour. So they start here, they do a complete turn. So they go to east, to south, to west and back to north. They've turned in a complete circle, and there are 360 degrees in a circle. So that is your answer. Okay, that's a fact that you need to know. Okay, there are 360 degrees in a complete circle. So the challenge is, how many right angles are in a complete turn or in a circle? Okay, so a right angle, no, that is as accurate as I can draw if I'm drawing freehand. So right angle, you can see them all around your house. So at the corners of your doors, or it might be you've got pictures hanging up. When you look at books, those corners, okay, that is a right angle, okay? And we often draw a line like that, and a right angle has 90 degrees. So we're looking here, and what I'm going to do is rub this out so we can see it here. Okay, so we're looking here. It says how many right angles have we got? So we've got one between north and east. Okay, we've got one between east and south, and that's not very well drawn, but you can see what I'm saying. We've got one between south and west, and we've got one between west and north. So there are 4 right angles in a complete turn or in a circle. So the answer is 4. Now, if we use the knowledge of 90 degrees is one right angle, then 180 degrees would be 2. Okay, I'm going to use my times tables, my 9 times tables. So 9, so 90, 18, so 180. Okay, so 3 there would be 27 or 270 if we're thinking about degrees. We use our 9 times table again. And 360 would give us our 4, so 36. We're looking at the 9 times table here. So 36 is our 4 times 9, so 4 times 90 would be 360. So if you divided 360 by 4, okay, because that's how many right angles we've got, our answer would be 90. Okay, so in a complete turn, in a complete circle, there are 360 degrees, and there are 4 right angles because there's 4 lots of 90 and 360. Right, let me know how you got on, and remember, what is this called?